Hello everybody and welcome back to the ASUS North America YouTube channel. This is JJ once again, and we're bringing you guys another feature overview. Specifically, we're going to be talking about a brand new feature and level of functionality we're introducing for our ASUS Z87 series of motherboards. So for you guys that are familiar with our motherboards, we've long had our dual intelligent processors design. This features both a TPU and an EPU processor, and they work in conjunction with our digital power management design in terms of the power topology and the power regulation to be able to essentially work with the UEFI and automatically overclock the system or make power adjustments for efficiency or be able to optimize for performance in a lot of different ways. So over the years, we've had a lot of different variants of how this functionality has been introduced, whether it's been something like our one-touch overclocking via the TPU switch, or whether it's been our full automated real-time system-specific auto-tuning technology, which would dynamically overclock your system based on the components that you had, the thermal solution that you had in place, as well as even the type of memory that you might be utilizing. For this generation, though, we've essentially taken it further. We've integrated 4 key aspects of functionality and rolled them all into one single application, with the goal of essentially giving you guys a high level of performance, efficiency, and overall making the process of being able to maximize the performance of your system considerably smoother, considerably easier, and while still maintaining a high level of performance. So what we're going to go ahead and be doing in this video is actually run through the 4-way optimization process, let you see what it looks like with a pre-built system like you would have if you were running it after you built your own system, and see what type of results and functionality we're going to have after we've completed the 4-way optimization process. As well as we're going to go ahead and detail what we have in place to give you guys visibility at how that's going to be affecting the 4-way optimization technology in itself. So with that, let's first take a look at the system that we have defined for running our 4-way demonstration. Okay guys, so we wanted to keep this as realistic as possible. So the goal here was to try to set up a system that essentially was representative of what a high performance Z87 based system would be. We didn't want to run anything in an open test bench. Even actually the internal environment that we have in here is actually, it's quite a bit hotter than what we have in our normal office environment, just because it's much more confined. We've got a lot more lights, so even the ambient temperature has been kicked up a bit more. And that's something to actually keep in mind because the 4-way optimization process in terms of the overclocking takes into consideration thermals. So with that, let's go ahead and take a look at what we're going to be utilizing. First off, we have a really nice chassis from BitPhoenix. So this is the BitPhoenix Ghost. We've selected it just because of the ease of the layout, the functionality that we have in terms of being able to put additional cooling points into it in terms of the 5 fans that we're utilizing, as well as easy cable management. Overall, a really outstanding choice in terms of a high performance chassis with a lot of flexibility. Now, talking about the flexibility, we've got 5 points of additional airflow introduced into the chassis. So we have 1 back chassis fan, so this is serving as an exhaust. We then have 2 chassis fans at the top here serving as an intake to bring cool air in, and then we, of course, as you see here in the front, we have 2 more chassis fans also serving as an intake to pull air in. Now, one of the things that we're also going to be showing you as far as this 4-way optimization process is that it will automatically calibrate and tune every single one of these fans as they're all connected to the motherboard. So that's a great technology that ASUS has implemented on a hardware level that's working in conjunction with our software, is being able to profile and tune the fans. Now, these fans, they're great in terms of offering a great level of flexibility at the maximum RPM and the CFM that they're offering, and these are the BitPhoenix Spectre Pro LED based fans. Now for cooling, which is going to be a critical component, we have Noctua's high performance NH series cooler. So this is their 140 millimeter heat pipe based cooler. It's got a great level of thermal dissipation abilities. Of course, it's got a really nice mounting mechanism with their secure firm installation. And then from there, of course, we know the quality and the performance of what Noctua's fans are offering. So this is a great choice of being able to give us something that's in the realm of being a performance oriented heatsink, giving us some definite overclocking headroom, but without necessarily pushing it to an unrealistic scope. Where of course, you could go ahead and even add an additional fan to be able to go ahead and have a push and pull configuration to even push higher in terms of the overclockability. In terms of the motherboard, we've gone with our mid-range series motherboard. So this is our ASUS Z87 Pro motherboard. It's running, of course, a 4th generation series Core i7 processor with a 4770K. Then for memory, we've tapped Kingston's HyperX Beast, a series of memory. So these are 4 DIMMs, and we're running at 2400. Now by default, we currently have this system at 100% stock operating frequencies. And so that means the actual memory is running only at 1333. We could could go ahead and enable the XMP profile, but there's actually a lot of people forget to do that. And one of the things that actually the four-way optimization process is going to do is not only optimize our memory, but it's also going to optimize the CPU. So we're in two things in fold that we're going to be taking advantage of. From there, for the GPU, we've got a high-performance discrete GPU featuring, of course, our DirectCU2 thermal design and our digital power implementation. For the storage capabilities, we've got a number of different items: an ASUS Blu-ray combo drive, we've got a Kingston HyperX SSD, and then from there, right below that, we've got a supplemental 2 terabyte Western Digital Black Series hard drive. So that pretty much gives us all of our key items, and rounding everything out, and something that you definitely don't want to compromise on is going to be the PSU. PSU is critical in terms of not only giving us great efficiency, helping to also monitor acoustics, as this is a one area that a lot of users forget that can actually emit sound from your system, especially under idle loads. And also we just want to be able to have sufficient high quality power delivery as we're going to be overclocking the system. So we have tapped Seasonic's Platinum Series PSU. This is their 860 watt PSU. So that pretty much gives you guys a quick breakdown of all the componentry that we're using in the system. As you can see, it's definitely a nice high-end system, but it's not at the bleeding edge of what you guys might be considering in terms of building. So now the interesting thing is going to see is what's going to happen when we go ahead and we run the four-way optimization process. So with that, let's go ahead and actually jump into the OS environment, take a look at the AI Suite 3 interface, and then from there jump into four-way optimization. Okay guys, so we're at our desktop, and like we said, we've essentially booted into the operating system environment for the system that we just talked about. And one of the things that you first off see is an entirely different interface. If you guys are familiar with ASUS series boards, you know that we've really prided ourselves on our system suite utility, which we've called AI Suite. Our previous generation AI Suite was AI Suite version 2. This generation we have AI Suite version 3. So you can see that we've entirely redesigned the entire front end of the application. So it's got a much more kind of a modern and edgy kind of feel. It's almost kind of like an on-screen display or a HUD type environment. Really our goal here was to give you guys a lot of persistent information, whether it's CPU frequency, DRAM information. You can of course get CPU loading information, your voltages, temperatures, fan speeds. You can go in and make adjustments to all these different values. It's all contained within there. And of course we have our TPU level of functionality, and this gives you full real-time advanced clock frequency control and voltages. And we've even introduced some really cool aspects, such as the ability to directly key in voltages versus having just a slider. And in addition to that, we have even gone in and incorporated color coding. The great thing about the color coding incorporation, as you can see, is that it gives you guys a much easier baseline of understanding the level of voltage that's being applied to your system, especially if you're not necessarily knowledgeable at where safe points, moderate points, and extreme points could be. Now, we talked about the four-way optimization utilizing our dual intelligent processors, which is the TPU and the EPU. So under the EPU portion of AI Suite 3, we've also continued to make some enhancements and some changes, including having the ability to do full real-time voltage reduction, or what's sometimes referred to as undervolting. That's available to you. You can set different profiles for how your system responds, whether it's at a high performance level or if you want maximum power saving. And with maximum power savings, you can even define more aggressive what are called TDP, or package targets for the amount of wattage that the CPU is taking. This is going to be great for you guys that want superior efficiency, especially at idle speeds. And from there, we can also even set away mode variables, which do some really advanced level of functions, such as shut off the power to supplemental add-in controllers like the supplemental USB 3 and supplemental SATA 6G connections on the motherboard. So the four-way optimization process, though, the great thing about it is that it's going to go through the TPU, it's going to go through the EPU, it's going to go through Fan Expert, and it's even going to go through our digital power management. So the Digi+ power design is something that you guys, if you're familiar with ASUS boards, we've had now for multiple generations. We've been leaders in terms of our power topology and our design and our motherboards, and have given you extensive level of control over each part of the way that the VRM works real time, whether it's going to be in the operating system or whether you controlled it in the UEFI. But with four-way, it's pretty much going to overclock your system via TPU. It's going to make full optimizations for power efficiency and power management with EPU. It's going to go ahead and optimize all the VRM operating parameters for the best stability and reliability. And then lastly, with Fan Expert, it's going to go through and do per header tuning to each one of the fans, where it's going to profile and calibrate the fans so that we can get that best balance information of how to optimally run the fans with different associated profiles, whether it's going to be silent, standard, turbo, or we've referred to it sometimes performance, or even full out speed. So with that, let's go ahead and actually jump into the four-way optimization process and see what our system responds to in terms of an improved result. Okay guys, so here we're at the desktop and we've got ahead and opened AI Suite 3, and you can see right here in the left hand corner we've got our four-way optimization button. So we're just going to go ahead and click on that, and that will take us actually into the four-way optimization screen. Now at this point, if you want to, you could just go ahead and click start and it would launch the four-way optimization process. But I'm going to walk you guys through a couple of steps to allow you to know how you can fine-tune it should you want to do that. First and foremost, you'll actually see that there's a number of different chassis configurations that are grayed out. And what you have the ability to do here is you can select each one of these, and once you select them, you can ensure that you've mapped the location of the fan in the correct location to where Fan Expert is going to be essentially registering that information for that fan header. So what we can do is we could say, let's click on the second connection after our CPU, and we could click on this button. And when we click on start, what it'll do is it'll turn off the other actual fans that we have connected, allowing us to know that the main fan that we're focusing in on is going to be the back exhaust fan. And we can go ahead and click stop, and we could then select back fan, or we could set side fan, whatever the corresponding fan location would happen to be. This is great for you guys that are maybe not always conscientious of where you make your connections. In this system configuration, we pretty much routed everything to where we wanted it to be routed to. The front intakes are closest to those ports corresponding on the board, so it all makes sense. But this is a really easy way for you to be able to map them out, and it also helps to work in conjunction with our Fan Expert 2 technology. And you can see that I have even gone ahead and gone to the point to rename the header itself. Instead of it being something generic, where like if we click over to the next fan header it says just chassis fan 2, I've already relabeled that one to back exhaust, and I could go ahead and relabel every single one of the headers to what I specifically want it to be read as. This makes it much easier that when you go into our probe software, we have the information right there to know what that corresponding fan is and how it's reacting. So it makes it much more visual there. If I could call these two, let's say front intake, and this is top intake, back exhaust, and that's a CPU fan, right? So it makes it much clearer. You could even call the CPU fan Noctua NH if you wanted to. It's really up to you in terms of being able to define that information. So a much more flexible design. Now, the next step is going to be the TPU. The TPU handles the overclocking aspects, or the auto tuning. And for this generation, we have two different ways that you can go ahead and overclock, either via the multiplier, the ratio, or via the BCLK. Fast tuning will be a very quick preset-based overclock, usually about 4.2 to about 4.3 gigahertz, and it'll execute in about 3 minutes. If you use extreme tuning, it's going to take longer, and it will be very specific to your system, as your cooling solution, your memory, your power supply, everything, your ambient temperature is going to affect the result that you're going to have. And this could run as little as maybe just a little bit over 3 minutes to maybe as much to about maybe 10 to 11 minutes, depending on how advanced your cooling and your system configuration may be. Your EPU configuration, of course, you have the ability to make adjustments into how you want it to be able to manage power efficiency and how you want it to be able to go ahead and optimize power. And one of them, as we noted earlier, is the configured maximum CPU power. That's that undervolting technology that we're talking about, where we supply less voltage to the CPU to have it be more efficient at lower levels so that it can consume less power. But by default, because that can potentially cause instability because we're providing less voltage, that is not enabled. But for you guys that want to be able to take advantage of that more advanced feature set, you can go ahead and enable it. The next option is going to be the fan, and that ties into the Fan Expert technology, where every single header will be profiled and tuned and calibrated to be able to go ahead and coincide with easy-based preset controls or manual controls that we offer within the Fan Expert 2 software in AI Suite 3. So with that, we're going to go ahead and set that we do want the benchmark to go ahead and apply. We've got the EPU set to its defaults and TPU set to defaults of ratio-based overclocking with extreme tuning. And from there, we've gone ahead and already mapped out our corresponding fan locations. So let's go ahead and start this auto overclock process. So at this point, you're going to see that the system will automatically reboot. It's at 100% full stock value, so that means under full core frequency, if we were to put it under full load, it's going to be 3.5 gigahertz, and the memory's running at its default 1333. So we're going to see how much of a performance increase we can get over that. Now, right now, by default, it's going to execute the first layer of the TPU stage of overclocking, which is going to apply a basic preset. And we've done an extensive level of testing to literally over hundreds of CPUs to find a consistent margin that CPUs are capable of, that this initial baseline goes ahead and loads in. So once this initial baseline completes, the system will then begin to go ahead and correspondingly increase the frequency and the voltage to go ahead and keep overclocking the system. And the great thing about it is that this will be specific to your CPU and to your cooling solution. As you know, different CPUs are going to use different levels of voltages, such as maybe one CPU at 4.6 gigahertz might require 1.150, another one might require 1.2, another one 1.25, and some we've even noticed with this generation up to 1.4. Of course, that means every single one's going to be different in terms of how much voltage it takes to get to that frequency and the type of cooling it would need to be able to reliably cool that frequency and that voltage. Now, one really key aspect of our auto tuning technology is that we're not going to increase the voltage. We're going to keep it in what's called an adaptive mode. That means that when the CPU frequency comes down, the voltage will come down. That gives us the best power efficiency, best thermal efficiency, and overall still allows us to go ahead and increase the voltage when the frequency goes up. So we get the best of both worlds. As opposed to manual overclockers, a lot of time they'll use a manual voltage, which can be very inefficient. So you can see here our system has already gone ahead and clocked in a 4.3 gigahertz overclock from us, which is already quite a big increase from the baseline of 3.5 gigahertz that we had. So now we'll go ahead and attempt to scale up the CPU frequency. Now if we go ahead and open up our task manager, we're going to see some really interesting things that occur. So as you can see right there, the CPU utilization is actually pegged at 100% because it's running a full stress test to the CPU. So this is running across all the cores, and it's exchanging a high level of instructional set information to be able to verify the stability of the system. It's pretty much the same thing a manual overclocker would do, is go ahead and define their corresponding frequency that they would want to shoot for, maybe make some voltage adjustments, and then go ahead and run a stress test application. Now we can see that it's passed that initial quick stress test, and now it's gone and proceeded to increase our clock frequency again. So we're now going up to 4.4 gigahertz. Now you'll see for this generation we've further refined and we've introduced per core tuning. Some CPUs may not always have the consistent ability to run all frequencies across all cores. So you can see we have 44X set for 1 and 2 cores, and 43 was set for 3 and 4 cores. And so now we've gone ahead and bumped it up again, and now we have 44 on both 3 and 4 cores. So we're going to continue to incrementally increase the frequency. We're going to make adjustments to the voltage. We're going to continue to run the stress testing. And in the background, the system will also consistently monitor for thermal throttling. Eventually, when it reaches a point of instability along with too much thermal throttle, it will go ahead and essentially say, hey, I've reached the effective limit of what we can overclock your system towards, and it will continue in the next stage of the four-way optimization process. Now, I do want to go back to the point that I noted on earlier, is that we do set a defined maximum voltage for our auto tuning technology of 1.275 volts. This is important because we don't want to ever provide too much voltage, even if you have a great cooling solution, because this is going to help us to ensure the best long-term reliability for your CPU, as well as help to control overall thermal considerations. Once you really start to actually exceed about 1.3 volts on this platform, if you don't have really outstanding cooling, it can become quite difficult to manage the thermal dissipation characteristics. Now, it wouldn't necessarily be that case if you're going to run real-world programs such as games, normal productivity, web browsers, and multimedia applications. But if you start to run very, very high-level applications such as rendering programs, transcoding applications, linear editors, or even synthetic stress tests, then you could definitely run into a point where at 1.3 volts, almost no standard thermal solution on the market would be able to control the thermal response that's being output from the CPU. So that's something to keep in mind. But that's one of the really great advantages that we have with our auto-tuning technology, is that it's specific to your system, your CPU, and your cooling. So we can see now we've continued to allow it to go ahead and scale. And even though we're in a very warm environment here, I'd probably say that on average our temperature in this room is probably somewhere close to about 80 degrees, maybe even a little bit more from some of the centralized heat that we're getting from the lamps that we have in this area. But you can see that even with this, our Noctua high-performance tower heatsink is doing a great job of providing us some thermal dissipation capabilities. We've got that solid airflow, and we can see now that we've gotten to 4.6 gigahertz, actually now just 4.7 gigahertz on 1 and 2 cores, and 4.6 gigahertz on 3 and 4 cores. So it's going to go ahead and continue to increase until essentially it gets to the point where it realizes, hey, I've either reached too hot of a point in terms of the stress testing, or 2, it's effectively reaching a point that the voltage needs to be continued to be increased past what our set marker of 1.275 volts is. So we're going to go ahead and just allow it to continue to go through this process, and we'll see what auto tuning ends up enabling us. So actually, we could be getting to the point, oh, no, it's still continuing to go through. We're actually now at 49 on 1 core and 2 cores, and on 3 and 4, we're at 48. So we've got a very aggressive overclock. As you can see, you know, we picked an outstanding cooling solution that we have here with our NOC 2 140 millimeter tower heatsink. Now you can see right there, the system has crashed. This is entirely A-OK. No worries here. We've already pre-designed the software to account for this crash, and we've actually adjusted the countdown timer. So the countdown timer is when your system crashes, you usually have a certain amount of time that the system takes for it to come back. We've actually shortened that. So you can see it's dropped down to a very small amount of time, 7 seconds, as opposed to I think the standard is about 30 seconds to more quickly reboot through this process. So we're conscientious that this is going to occur. And pretty much what happened there is it got to either one, too hot, too much voltage, or just the frequency headroom wasn't there within the CPU. So at that point, the utility logs that information, creates a composited average against the information that we've internally compiled with testing hundreds of CPUs, and helps to then approximate what's the recommended frequency after we've tested everything. So momentarily, the auto tuning application will come back up and notify us of the new frequency that it's gone ahead and achieved. And it's actually been successful. If it hadn't been successful, it would not continue through. But you can see right here, it's actually continuing through the 4-way optimization process, and we've now gone to the next step, which is going to be our EPU, or our power management adjustment options. So here it's going to go ahead and do a number of different adjustments to be able to set better points of efficiency for our system when we're, let's say, in away states or in idle states. And it's gone ahead and plugged those in. So now next, it's going to go through the fan expert process. So the fan expert process is something really cool. If you guys take a look at the fans that we're going to have, you're going to begin to see the actual fans curve down and eventually go to the point where they're going to turn off. Because what we're doing is we're essentially detecting each one of the fans per each one of the headers, and we're monitoring their maximum level of operation and their minimum level of operation. So like there, you can see those front fans are starting to move slower and slower and slower. I think the bottom fans, yep, the front intake fans essentially just turned off because we've realized what was the minimum operating metric of that fan. Now this is important. Why? As we target in this information and we profile the fan, this allows us to take our presets that we have, such as, let's say, silent or standard or even full speed, and know how to optimally utilize them. If we now click silent in the future, actually the fans aren't just going to become quiet, they're actually going to turn off. So it allows us to really take the best advantage of how we have our system and not only create that best balance of acoustics, but also be able to optimize for airflow depending on what your configuration is. So it's going to continue to go through the calibration process here, logging all the information, and this is all occurring real time, stored per each one of the headers. It wouldn't matter whether we have 3-pin base fans or 4-pin base fans. You have a huge amount of flexibility. The NOC 2 CPU cooler that we're utilizing uses this awesome high-performance NOC 2 PWM or 4-pin base fan, but the actual Spectre Pro LED fans are 3-pin fans that are connected to the motherboard. So we have the flexibility of tuning all of those. So once it goes through all of this, it will store all of it, go back to a standard profile in terms of the fan configuration. But the great thing will be is that at any time we can now easily just go to those presets and we could click full speed, we could click silent, we could click standard, and it's going to optimally take that information based off of what's been calibrated off your fan, as opposed to being some approximate curve. And keep in mind that actually the majority of the motherboards on the market don't even have any level of this type of control offered for multiple headers on the motherboard. All our motherboards all the way down to something as our basic as our Z87-A feature our Fan Expert 2 technology. So a really nice level of functionality introduced on a motherboard for when you're optimizing for either acoustics or optimizing for, of course, maximum airflow flexibility at how you have that set up in your chassis. Now you can see here the fans have pretty much ramped back up. Now they're targeting back down to a basic profile because we're about to complete the Fan Expert tuning process. So overall, we've taken, in total, we have the 2 front intake fans, the 2 top intake fans, the back exhaust fan, and then our CPU fan. And that's all been run through. And the last portion, the digital power management or DigiPlus power optimization was occurring during the dynamic overclocking process. So as you can see here, we've now gotten to the final page. We've completed the entire 4-way optimization process. And if you keep in mind the fact that most of you guys aren't going to be knowledgeable about the platform in relation to temperatures, voltages, or a number of the different configurational aspects, we've essentially completely overclocked our system. We've tuned for power efficiency. We've gone ahead and made a great deal of tuned configuration to our fan profiles, and all in a very short period of time that honestly, even if you're an enthusiast, would take you hours upon hours to figure out all these points of data, get them plugged in, and get them situated to leave you with essentially a running box with this level of performance and this level of efficiency. So we can see here our overclock, quite strong. It actually finalized at giving us 4.8 gigahertz across 4 cores. So that's a huge increase in terms of the frequency when compared to the baseline all-core frequency of stock, which was going to be 3.5 gigahertz. For our EPU, it's gone ahead and made some optimizations in terms of the power management options. And for our fan expert, we can see here that we've gone ahead and cataloged all the fan data information. So you can see there's the RPM values for the fans, and it tells you even where the RPM values stop in terms of how they work. And we can click through each one of these, and we have information per every single one of these fan headers. So that's great. And then from there, if we go ahead and click back out, you can see now that the actual four-way optimization screen and the first page of AI Suite 3 has some additional information, such as the increases in our CPU performance. All the fan headers have actually all been calibrated, and we can see that if we highlight each one of these. We have a huge amount of flexibility, and even if we want to, let's say, maybe jump now over to the Fan Expert 2 section, we can go ahead and take advantage of the calibration process. So if I was to go ahead and now press full screen, full speed, you can see all my fans have all fully ramped. So they're all now running at full speed. But let's say maybe I'm just going to go ahead and be surfing the internet. Maybe I would just want to open my browser, right? So if I was to go ahead and just connect to the internet, why do I need to have my system performing in that respect? There's no reason to, right? I could go ahead and just click on silent, and if you're going to see, what it's going to go ahead and do is going to turn off all the fans. That allows me to keep the quietest level of operation for my system. And even if I was to all of a sudden from here jump into a game, the silent profile is still set with a fan curve, as you can see right here. So that means that once it gets to a certain temperature, the fans would still actually automatically come back on. So even if I wasn't conscious of making these changes, it would occur right off the bat. So you can see a great deal of flexibility. Now with that, we're just going to show you one last portion, which is going to be the effective frequencies. So let's go ahead and just open up something like our ADA report, and we'll take a look at our finalized frequencies that we have. So here we go. You can see, one, we're getting an immediate advantage from our four-way optimization process. As we talked about, manual overclockers, you generally will not receive this type of benefit where you can see that our CPU frequency, it has dropped down. We have a great idle voltage. We're running what it should be, as opposed to if you had a manual overclock of 1.3 gigahertz, my voltage here would be fixed at 1.3, and then my frequency would be fixed. It would be really inefficient, be producing more voltage than I need, more heat than I need. And here, we're dropping down the voltage, we're dropping down the frequency because the system is maximized for efficiency. And we can also see right there, our memory has been increased to 2133. So not only did we reach that 4.8 gigahertz, but we reached that 2133. So now let's go ahead and round this out and confirm that we actually have our 4.8 and our 2133 successfully stable. So we're just going to go ahead and run something along the lines of Cinebench. So give me a second here to go ahead and open that up, and we'll get this running. Okay guys, so we just need to switch out memory cards, but we're back here at the desktop. We still haven't changed out anything. All we've done is actually go ahead and load up Unigen. So what we're trying to show you here effectively is, one, is that game engines, as well as everything that you do, actually doesn't really load the CPU at all in terms of effectively really creating a lot of thermal load, as well as also maximizing out the CPU frequency. So you can see right here we're running Unigen, which would be pretty much comparable to almost any type of high-end modern game in terms of what you're running. And on average, you're usually going to be somewhere between about maybe 15 to maybe 40% in terms of actually CPU utilization. And that would be more likely, especially if you're doing online gameplay multiplayer maps, especially with a high level of AI simulation. But what we're going to go ahead and do is we're going to quit out of this now that we've had it running. And once we go ahead and escape out of that, we're going to go ahead and run Cinebench. So we're going to keep this CPU ID utility open from Ada, and we're just going to go ahead and run this to go ahead and verify our 4.8 gigahertz. And as we can see right here, now it's gone ahead and ramped up to our 4.8 gigahertz. We've got the 2133. It's actually pretty much right in line with where the voltage is that I told you that it peaked out at. So at 1.275 in terms of the voltage being supplied to the CPU. We're hitting all the cores at a maximum 100% load with a very heavy render file in terms of what we're doing here in Cinebench. So this is a great way to be able to verify in a quick way the stability of the platform outside of the stability test that we've done. In our internal analysis, the auto-tuning technology and the four-way optimization process is very effective at being able to overall provide you a solid, efficient, and reliable result. So we can see right there, it's gone ahead and completed that, and that gives you guys a little bit of perspective and the advantages of what we can offer on our Z87 series of motherboards with our four-way optimization technology, which is powered by our dual intelligent processors for implementation. So with that, let's go ahead and wrap things up. Okay guys, so we've given you a overview on our brand new four-way optimization technology that's part of our AI Suite 3 system utility that's powered by our dual intelligent processors for technology on our ASUS series of Z87 motherboards. Hopefully you guys have found that this really offers an entirely new way to be able to approach your system in terms of maximizing its performance capability, tuning aspects in terms of acoustics and thermals with FanExpert 2, being able to automatically tune and profile the power management options as well as power consumption via the digital power management that's offered within the four-way optimization process, and even working in concert with our EPU technologies. So overall, I think we've shown you guys a really impressive level of functionality in a real-world system, you know, that we're utilizing a normal type of system that you guys would build. So hopefully you guys found this interesting and informative, you know, and as always, if you guys enjoyed the video, if you have questions or comments, we'd love to see them here on the page, so make sure to drop them into the comment section. If you want, also feel free to hit us up at our ASUS North American Facebook pages or our ASUS North American Twitter pages. And if you enjoyed the video, please make sure and subscribe, as well as thumbs up and like the video. So as always, stay tuned to the channel for more videos, and thank you for watching.